difficult. Okay, so you should have all got notifications about the recording, is that right?
Yeah, notify.
Okay, so just in case I put this on YouTube, we got my name's Mark Simpson. We got Bill Yeung with us and Eric Klaszus. So yes, I'm just going to have a quick discussion about how to analyze recordings in PyMovie and PyOTE. Okay, then. So first thing we need to load a video. Okay, so I'm loading a video here. And first thing we need to do is just adjust the contrast here. So I just clicked on Show Image Contrast Control. I just want to get those stars so I can see them. So I just pulled up the bottom here and the top down. And yeah, that's good. And then we just switch this off again so that it sticks. Otherwise it will go when we switch to the next frame. Okay, so we need to put some stars on. So first of all, we need to know where our target is. So this guy here is our target. So what I'm going to do, I zoom in. And then I add an aperture here. Now I'm going to add 12 nested fixed radius mask apertures like that. And I want to get it centered on the star, okay? And that gives us a whole range of apertures. And then we can pick the best one later on, right? Now, if I click view or right click and view all here, that brings me out to the full screen. The other thing we need is a reference star. Now, because this event has a lot of clouds, I'm going to pick a star close. The reason being because the cloud moves through, so it will tend to impact both stars at the same time. If I pick one that's right
Good
out
point.
here, then there could be a delay of half a second or a second until that one and that one gets hit, right? And then you can't really normalize about it. But I want one roughly the same brightness. I don't want one that's too bright, too dim. If it's too dim, it'll probably disappear and you won't be able to see it, so it's useless. And then if it's too dark, so if it's too bright, then it will tend to saturate and you'll be using different mask radius, right? And also you have a stronger signal. So you really want something that's about the same signal strength. So I'm going to pick this one here and I'm going to call this one, so I'm going to add a static mask for this and adjust the value later, okay? So we're going to call this one reference, okay? And then those two are done. Now, we need some tracking stars too. So the thing with tracking stars is you need, if your movement is translational, so in other words, if it's an equatorial mount, then you want, and it's being moved in predictable ways, then you want just one, you can get away with just one tracking star, right? But if it's an alt-az mount, it's going to rotate around that way while it's recording as well, right? So then you need two tracking stars so it can pick up the rotation as well as the translational movements, okay? So I'm going to pick two tracking stars. Again, not too bright, not too dim. I'm going to pick this one. This is quite a good one. It's not too bright because you don't want it saturated, right? So I'm going to add a dynamic mask aperture on this one and call this tracking one. Now, you really want this one far from your target because the further it is away from its target, the more accurate the translations and the rotations that it applies are going to be, right? But you don't want it out of screen, right? So this one isn't really very good because it's right at the edge. And if it shifts, it might move the aperture and then the aperture hits up against the edge and it can't track anymore, then it sends the tracking off, right? So so on this one, I'm going to pick this one here. Again, dynamic mask aperture, tracking 2, okay? So we now got those two set up. First thing I'm going to do, I'm going to mark it, okay? The current frame is 0. When I mark it, it saves all those settings so I can go back to it later by clicking back to mark, okay? So now I just do the analyze. So off it goes and analyzes it. That's basically how you set up. And you can also save these apertures as well as an aperture group if you want to. And you can always access your aperture settings by just clicking on Examine Apertures.
So, Mark, do you always use a dynamic mask on the tracking aperture?
Yeah, so tracking always use dynamic. For everything else, I use static.
What's the difference, if you don't mind?
Yeah, I'd read a couple of times that static is better for the actual data, and dynamic's kind of like a shortcut. So for tracking, it makes sense to change the mask size automatically, but for the actual data, that can cause problems. That's what I've been told. So so that's the reason I use static for the reference and static for the main one. And you can see we've got all our mask sizes down here that we've picked. So when we add 12 static masks, that's what it did. It just added those 12 there. Okay, so that's done now. Now, first thing I do is look at plot, and I just see if I got a signal. Okay, so first thing I see is there's obviously a lot of cloud issues. So you can see the signal is quite strong at the beginning, and then it kind of dropped down. Okay, as the cloud came in. So we know we've got a cloud problem that we need to deal with. Now, where's the event? So generally, with the robustness of the calculations, if you get pretty much all the apertures dipping at the same place, then that's where your event is, right? So if I look here, this one here, it's only the smallest, it's only the reference that dipped at that point, right? So that's not going to be an event, right? But I can see here there's a majority of plots actually dipped there, so I know that's where my event is, right? It's just a robustness thing, right? Any signal you just get on one plot is not really a signal. If it's on every single aperture, so if it's on every single radius, then it's a signal. You know, from a robustness point of view. And we know we should be getting a decent, you can see that here. So for instance, this one isn't, that one is, because we've already ascertained that is, right? But you'll notice that changes throughout, right? So as we go forward, this now doesn't look like a signal. Now we're up to radius 5.1, but this is still showing as a signal. But we've got another blip there, but that could also be noise too, right? But generally noise will disappear as you change radius, can you see? But the signal will always persist because that's in all the data, right? So essentially what you do, you change the analysis, right? So as you change the analysis, you'll see dips come and go, but where it's always there, you know that's a real signal. Okay, so we've done that now. So if I want to go back to the beginning now, I'd just say back to Mark, okay? And it would return all the apertures back to the beginning. Now, so we've done our analysis. Next thing we need to do is write our CSV. So I'm going to, so a little shortcut. I'm just going to delete some files here. Just bear with me, just so it goes back to normal. So I'm going to delete. I'm going to keep the spreadsheet. It's just a nice little trick to save you having to. So what I've done here is I put a folder with Eric. So I've made a folder for the event, right? And in there I put the folder name, and then this can become the zip file later. And I put the XLS in there and the spreadsheet, and then I just created one for the video as well. So so what I can do now when I save my CSV is I've got this here, right? But I don't want to have to enter it, right? So I just go all files, click on that, that gives me the name, excuse me. And then I switch it back to CSV and it'll put the CSV on there. And then it will create all the files with the correct name. Just click save, okay, and it launches PyOTE. And you get a load of apertures, obviously, right? Now, the first thing is, we know we got cloud, right? Now, there's 0 point in normalizing if there's no cloud. So if there's no cloud issues, don't bother. It won't make things better. It won't solve anything. It'll just waste your time and you'll get the same result, okay? Possibly even worse, right? But if there is cloud and there's variation in the light curve like that, and it's always fairly obvious, right? If it was all fairly level here, even though it's noisy, then that doesn't require it. But if it's like varying in light level like this one, then it requires it. So we got a bunch of light curves down here, right? And first thing you notice is they're not all displayed. We've actually got other ones down here that aren't displayed. So we need to grab the reference one because we're going to be normalizing against the reference. So I just select that down there and it adds reference at the top and it removes the first 2.0 because it can't display all of them, right? So let's pick, so we've got our reference and we're going to pick, now I happen to know it's 5.1's the best, but let's assume it's not. Let's say we start at 4.3. Okay. Now with the apertures, so I click here, right, and target, and it switches that to the target, and then I can put ref for my reference here, and I can either show it or not show it. So I've now specified a reference, which is the reference signal, and I got my aperture. Now how these apertures work is if I go back to PyMovie here, can you see this? You've got a center point here, and then you've got a number of pixels. So when you zoom in, so basically we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that immediately tells us if the diameter is 12 pixels and we divide that by 2, that gives us our mask radius, which is 6. So we already know our mask radius is going to be around 6 for this particular star, right? Bigger the star, the more space it takes up. But we already know we're going to be around the 6 area. So there's probably not much point in bothering with a radius of 2 or 2.4 because it's only going to encompass part of the star, then we're losing part of a signal, right? And there's no point in putting 12 because if it's a 12 radius and it's 24 diameter and that's far bigger than the star, and then we're getting too much background, right? So we already kind of know what it's going to be roughly anyway, and we're just optimizing around that point. So, I've got a range here from 2.4 to 7.2. That's probably good enough to encompass everything that makes sense in terms of radius. So first thing we need to do is normalize, and to do that we need to figure out how large our dip was. Okay, so we count the frames: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so our dip was roughly 11 frames. Okay, so I'm going to put in here 5 as the minimum event size and 20 as the maximum event size. Okay, so that says it's going to look for an event between 5 frames and 20 frames. Okay, and then I don't have to know exactly what, I don't have to mark DNR or anything like that, because we're going to have to keep repeating the process regularly to get our most optimal settings, and that's one way you can do to save on the calculation time and the clicking and stuff like that. So back to the light curve. So I brought this back out to the full size again. Now to smooth the light curve, we need to mark a baseline, because we need to know statistically like how good the signal is, right? And the baseline doesn't include the event, it includes everything but the event. So what we do is we click, so you see, just mark it. So I mark that one red, and I'm going to mark up to some point before where I can see the event is. So I'm going to mark there, and I'm going to click mark baseline region, and it turns orange. Okay, I'm going to do the same on the other side. So let's say this is the end of the event here, and I'm going to mark up to there. I'm going to mark baseline there. So now we've got a baseline that we can calculate statistics on, but it excludes the event. Okay, so now what we do is we click on find event. Okay, and it will tell us, it will give us our event just like it would normally. Okay, and we've got a DNR of 1.59, which is pretty bad, right? Now we've got ref to normalize, but at the moment we're not smoothing any readings, so this is our raw data essentially, right? So I'm going to up this by 1, and it goes up in units of 2, so it's now got 2. Okay, and you can see now this line's now become level, right? So it's leveled out our baseline. So we can do find event again, and you'll see here it's got 5216 for the flatness. Okay, now as we go up, we want to, so we go up again, smooth the readings again, 4, and you see that's now dropped to 5089. We want to minimize this number until it doesn't really change much anymore. If it starts going up, we want to stop. So as I keep upping this number, it's 5029, 5002, 5023. So now it's gone up at 10. Okay, so now it's going the wrong way. We go 12, etc. It keeps going up. So this is no good, right? We're making matters worse. But at 8, that seems to be about the optimal value. Okay, now for smoothing for cloud, it's typically going to be around 10. Okay, if you're getting to like 20 or 100, you're wasting your time. You've gone too far, right? So you always want to look for a value that's around 10. If you're getting nonsensical values like 20, then set it as 10 and be done, right? If you need it. But again, don't normalize if you haven't got cloud, because you're just going to make matters worse. There's no point in doing it, right? But in this case, obviously it's so bad we need to do it. So we found our normalization value there, and if I click on find event now, it's going to search for that event in that data. And we got a DNR of 3.6, okay, which is significantly better than before. So now we're going to go through our apertures, right? So I've got 4.3. So I'm going to start off at 3.2, okay? And we're just going to work up, okay? So find event. So we know what our smoothing is. Okay, now we're doing the find event. So when we find event, we've got DNR 3.43. So I'm going to try another one. So remember that 3.43. It's gone up to 4.63. It's still getting better, so we do it again. So at 4.3. And you notice it's not popping up the graphs all the time, so you don't have to click on stuff. So it's 3.6 now. Do we find event again? That's 4.12, right? So we're just trying to maximize that DNR value. So it's going down now. So far 5.1 was the best. And we're just going to do a couple more and just check it's still going down. And that's essentially just where finding the peak is, right? And that's pretty close to the 6 that we estimated. 3.97. Okay, so I'm going to call it 5.1 to get rid of displaying the others because we don't need to see them. Okay, and then we've got our value. So now we know it's 8 is the smoothing readings and 5.1 is the aperture, okay? So I'm going to get rid of this now and I'm going to clean stuff up. So I'm going to go back to Mark and I'm going to get rid of all the apertures that I don't need anymore, okay? Because there's no point in having around, it just confuses the reviewers. So I'm just going to delete that one, 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 delete that one. Okay, and I'm going to call this one target. Okay, now our reference is still 3.2, which was the default, okay? So I'm going to change this to 5.1 so it matches. It's about the same size star, so the reference is going to be about the same radius, mask radius, right? So I'm just changing the reference to match, so we should get a, now the aperture fits the reference as well, we should get even a slightly better result, right? So we're now done our apertures. It's very important before you edit apertures to click on back to Mark. If you're not at 0, then when you edit it, you'll mess up all your apertures, and just seems to be, I don't know if it's a feature or a bug or whatever, but that's how it works. So always go back to Mark before you edit your apertures. Okay, now I'm going to mark it again. Okay, so I've got the new aperture stored, and I want to clear the data because I want to recalculate everything. Okay, and then I'm just going to delete the files that I didn't need anymore. So I'm just going to go in my folder here, and I'm going to delete not the XLXS, because that's the one that I'm going to need later to automatically fill in. But I'm going to delete those, okay? And then I'm back to normal. There you go. So now I'm just going to analyze again, and it'll be a bit faster this time because it's not doing 12 apertures this time. Yeah, you can see that cloud come through, but so you can see, you're going to be okay because you can still see the star above it, right? As long as you can see the star above it in a single frame, then you've always got a reasonable signal, right?
Yeah.
So That's done, and then we write it again. So we write the CSV again. Go into that folder. So again, the same trick, all files, click on that, switch back to CSV, and then it's got the name. Okay, and then we save. Okay, then it launches a PyOTE. So we need to do the same thing essentially. So what I'm going to do, I'm going to put in, what do we have, 5 and 20 was it? So I put 5 and 20 in there. I'm going to set the reference, and I've got the targets already displayed, right? And I'm going to normalize by 8. So I put the 8 value that we determined before. And I'm going to switch I'm just going to not display the signal reference because it just makes it a bit clearer. Okay. And then I'm going to, so we've got signal target, signal reference. Then we're going to click this time on find event here. Okay. And it's found our event. And we've got the red bar now to the far right of the green. Okay.
That looks much better.
A lot better now. We've got something to work with. Okay. So red's to the right, the 3 greens, so that means we're good. Okay, and then what I'll do is frame it, and then we do our fit metrics. Sorry, let me try again. We do our fill Excel report, select the XLX. And it will launch the spreadsheet. In a second, it will launch the spreadsheet. It just takes. I'm doing some image processing at the moment, so the machine's a little bit slow. Actually, maybe there's something else going on. Let me just try again. Oh, there it goes. It just launched and then I killed it. Okay, let me try again. So I'll just launch that. There we got our spreadsheet. Come on. There it goes. And then you fill in the observing location. Then fill in your clouds, your stability, and the other conditions, and you're done. And basically in the times in there. And yeah, that's essentially it. Any questions?
When you were in the light curve tab and starting to go through all of the find event for every aperture,
Yeah.
did you have I can't remember, was there some of those apertures were still showing the original like drop in the cloud for each event? Does that matter, or is that reference normalization applying in the background to everyone?
So basically how it works is it only normalizes the target. So if you had that aperture selected as a target, then it would normalize that, but it won't normalize the other ones that are listed that aren't selected as the target. You can only select one target at once. So essentially all it is that raw data is being displayed, and you can choose not to display it. So for example, I can display tracking 1 here or tracking 2, right? But if I wanted to normalize tracking 1, then I'd have to select that as a reference. Sorry, if I was to normalize tracking 1, I'd have to select that as the target. Otherwise, it's just data that's being displayed, and you don't have to display it. Now, on every iteration, you could go and just disable the ones you didn't want to see as well. I just didn't because it's extra clicking, right? But and it doesn't really matter because you're just trying to optimize that DNR value down on the
Right.
right.
And at the end of the day, it's just looking at the raw data anyways, right?
Yeah, that's right. Yeah. So for example, if I was to select, so we got the target at the moment, right? If I was to, let's zoom this out. If I was to not have this as a reference, you can see it goes back to the original data. And if I select it as a reference, it and then I don't show what's going on here.
Oh, I think the smooth reading went back to 0.
Oh, it went back to 0, yeah. So you kind of got to watch these settings. They keep on changing on you as well, just to make life difficult. But yeah. So yeah, that's basically how that worked. If I want to do it with tracking, so say for instance, this was another aperture. In this case, it's called tracking. You can see the blue signal here. And I was to then change that to the target, it will now normalize tracking, right? However, I've still got target showed, right? And target now is the original raw data, which is the red one. So I could choose not to display it, and then it would look good.
Oh, okay.
Now, interesting, this one. Now, do you remember what I said about you want the reference signal to be close to the target star? The reference signal is not close to the tracking star, right? Because the reference signal was here and the tracking star was up here, right? So this is a very good example how it's very difficult to normalize for cloud when you pick two stars that are far apart, right? Because it's hitting one part first. Now you might find you get a better normalization as you up. You can see it's sorting itself out a little bit, but it's not really fixing itself, right? And 68 is just way too high a value to be practical, right? So it's a very good example why it's improved things, but it hasn't fixed it, right?
Yeah, that's interesting. Yeah, it doesn't quite level it completely off.
That's right, yeah. You see, whereas with the target star, it does a lot better job. So yeah. Any other questions?
Very cool.
So this one, I think, is the most extreme situation, right? Because if we have clear sky, then we don't have the problem. This one, not only do we have drifting cloud, and also the magnitude drop is not that much. So this is really maybe the trickiest kind of case.
Yeah, these ones are the difficult ones. The other thing as well I'd add is that if you don't have the cloud problem, then you're still left with trying to optimize your signal to noise.
Yes,
right?
true.
The best result. So you can skip marking the baseline region, and you still want to fill in these two to bracket the duration. And you don't have to click out reference. You don't have a reference selected, so it would look kind of like this, right? And you wouldn't mark your baseline, and the baseline's only needed to get those flatness values, right? It's not needed for any other purpose. So once you determined what your smoothing readings is, you don't need that anymore, right? But when you're just doing just a regular event with no normalization, then you don't need mark baseline region. All you're doing, and that will be 0, obviously, and all you're doing is just click find event, right? And then you can quickly go through and get your SNR without having to get those charts popping up with the red lines and green lines and stuff like that. It just saves you a bit of time of when you're trying to get through a bunch of apertures fast. A bunch of masks fast to see which one's the most optical one, most optimal one. So any other questions?
I think that's a huge help.
Okay.
Yeah.
Sounds good.
Yeah.
Please send the video because the clicking out is a little bit fast. So with the video, we can recap what button I can recap what button to hit. Yeah, things like that.
Sounds good.
Yeah.
I'll stop
Thanks,
the recording.
Mark.
I'll stop